Welcome to my home. Today I am going to do the lesson from home. I'm not feeling 100% today. I don't have really a high fever or anything. It's right around 99.7, but I don't want to chance anything and get out and make someone else sick, or it could just possibly be my sarcoidosis acting up. And so I'm going to stay home, protect myself, protect others. And so today is day 17, AMI packet number 18. For some reason I'm clicking the next button and it's not wanting to go to the next screen. There it is. Okay, so today you are going to need 6.3 applying Newton's law of motion worksheet. If you don't have it, but you have the availability to watch this, which means you can get online. Make sure you go to Lamar Warrior's website and over to AMI packets, high school science 16 through 20, and this is day 18. Just scroll down where it says science. Mine says physical science 16 through 20, and then today is day 18. It is Wednesday. It's Hump Wednesday, so hopefully everybody has had a good week so far and you've been very productive on working on your AMI packets. If you are not available to get the packet printed off, get a piece of paper, write your name, physical science, AMI day 18 in the top right-hand corner. You will need a writing utensil. You might possibly need a calculator today. There are 8 questions, which is your assignment today. You're going to fill in a table and then answer 8 questions. It might need a calculator for 2 questions. Okay, so if you've already got all that, we're going to go straight into it. Today is just a review of Newton's first law, which we did on Monday, Newton's second law, which we did yesterday, and then Newton's third law, which is one of my personal favorites and one of the easiest ones to remember. So let's do a quick little review. Remember, Newton's first law says that if an object is at rest, it's going to stay at rest. If an object is in motion, it's going to stay in motion unless acted upon by an outside force. And in that one, we're looking at the net force, where if we have an object that is resting, so let's say I've got my phone is resting on my hand, my phone has a weight, which is the mass times gravity, so its force is pointing down towards the earth, but what's pointing up towards it is its normal force, so those two forces together create a vector, and those vectors together, if this phone is at rest, then it has a net force of 0. Same thing if I had got a little orange here. If I had an orange rolling, this orange is going to stay at constant velocity. And if it stays at a constant velocity, which right now it's not because my hand's not constant velocity, then its net force will also be 0. So in illustration, we've got a soccer ball. Soccer ball is sitting there. It's at rest. Then an outside force comes and kicks it. That ball will then be in a constant velocity, having a net force of 0 until it has another outside force that stops it. So that is Newton's first law. Look at your table. Let me just do a quick reminder. I'm going to go over the table. I have it pulled up here real quick. Today's table, it tells you, it wants you to fill in Newton's first law definition in your own words. Look at my table compared to your table. It could be completely different. It is completely different. Yours says to write the laws in your own words. My table is giving you the definition. So you take the definition that I'm giving you and write it in your own words. Then it wants you to give an example of the law. You can either write out an example or draw an illustration of the example. Either way it goes, it's up to you. Maybe you want to take your phone and show it at rest. If you want to take an orange and show it rolling, it's up to how you feel like that's the example of the law. Okay, so let's go back to here. Okay, so Newton's second law has to do with acceleration. Remember, we talked about acceleration, where force equals mass times acceleration, where the acceleration of an object is directly related to the force on it and inversely related to the mass of the object. So if we did the little triangle, we got the force at the top with the mass and the acceleration at the bottom. And when it says it's inversely related to the mass, it's because force is on top, mass is on bottom. If I wanted to get acceleration by itself, it would say acceleration equals force divided by mass. And so it's like looking at a car. Car has a drive force. With that drive force, you have air resistance going against it. And we also have friction going against it. So when those two negative vectors go against a positive vector, it has to accelerate to keep going. And so that is where Newton's second law comes into play. And then our third Newton's law, force is a push or a pull that acts upon an object as a result of its interaction with another object. This is our favorite one where we learned about for every action there's an equal and opposite reaction. So we have a young man standing on the side of a boat with one leg off. If he doesn't have his balance, if his weight and normal force are not balanced with a net force of 0, and he's got more weight distributed on the other foot, he is going to splash in that water and get a little wet because the force of gravity is going to pull him down because he is no longer in balance. He is out of balance. So today's work is fairly simple. Let's do number 1 together. Let me move my head around here. There we go. Number 1 says, so get your piece of paper out. If you've already filled in your table, you might want to pause now if you haven't and get that done first because it's going to help you answer 1 through 8. So if you need to pause me, pause me. All right, if you are done with that table, let's go on to number 1. It says, when Jane drives to work, she always places her pocketbook on the passenger seat. By the time she gets to work, her pocketbook has fallen on the floor in front of the passenger seat. One day, she asks you to explain why this happens in terms of physical science. What do you say? Well, I got a little picture up here of this car going. There's no driver, but it looks like it's sitting. And her little Louis Vuitton pocketbook, or a wallet, whatever you want to call it, sitting on the seat. So the first thing I ask myself is, what do I want to answer? For some reason, my computer is taking forever, and it's not wanting to go to the next screen. Let's try this down here. There it goes. What do you want to find? Well, what we're looking for is the reasoning for why the pocketbook falls on the floor on her way to work. So the next thing is, what do I know, or what do you know, thinking about the 3 laws? Well, first thing you know is the car is a drive force that reacts against the friction in a balanced system. So that's something you know about driving. You also know if Jane needs to stop for a stop sign, light, or traffic, the sudden stop would put the pocketbook in an unbalanced system. So now we're going to solve it. I just want to know, is this Newton's first law, second law, or third law? If you said third law, you were correct. Because the weight and the normal force are off kilter of one another, just like when we saw the guy teeter-tottering on the boat, creating an off balance through the outside force of the car coming to a stop. So in this instance, the outside force is the car's acceleration going to stop. Because whatever you are inside of a vehicle, if you're going 75 miles per hour, that's what your odometer says. No. If that's what your miles per hour say, maybe it's odometer. I cannot think today. Then you are essentially going 75 miles per hour. You are not at rest just because you were sitting in that car feeling like you're at rest. You are still moving. Your body is moving with the car. Same thing with that pocketbook sitting on the side beside you. When it comes to a stop, our seatbelt holds us back, but that pocketbook doesn't have anything holding it back. That's the same thing as if you have anything in the back of your car with a bunch of junk, which I know a bunch of you teenagers are going to have, and you think it's at rest, you go from 76 miles per hour to a stop, everything in your back seat is all going to fly forward at 75 miles per hour to a complete stop. And so that happens because of the third law of motion. So now it's your turn. So get out your worksheet. We've done 1 together. You now need to do 2 through 8 on your own. Make sure you read the question before answering the question, because not all of the questions are asking you, is this first law, second law, third law? Some of them are saying, no, if we know what mass and acceleration is, which law are we going to use? Well, if you know what mass acceleration is and you're looking for force, you better know that it's going to be number 2. There's another one that says, if you know that the force is, let's say, 1 kilogram per meter second squared, and then it gives you 1 Newton, 3 Newton, 5 Newton, you know that that unit, kilograms times meter per second squared, is a Newton, so your answer would be 1 Newton. That is very simple. If you have issues today, please let me know. Holler at me. I am available until 3:15. Some of you have already messaged me. I had someone message me at 4 o'clock this morning. Messaging back at 9 a.m. because I'm not up at 4 a.m. So don't get mad if you're like, Miss Little, you're not responding to my messages, well, I'm not up at 4 and I'm not working until 7:45 to 3:15. So I really don't have to respond to you until 7:45 the next day if you've messaged me at 4 a.m. All right, quick reminders. May 1st is the deadline for your 10 AMI assignments to keep your same grade from the third 9 weeks. Second deadline is May 15th. If you want to increase your grade by one value or by one, go from a B to an A or a C to a B or from a D to a C, those 10 additional AMI assignments are due by May 15th. Okay, quick, easy lesson today. If we were at school today and I was giving this lesson, I'd sit back, relax, and get ready for the next lesson. So, hope you guys are having a blessed day. Miss you. Love you. Holler at you later.